and thank you for joining our Signal Media webinar, Use AI to Achieve Continuous Software Quality. I'm Diego Lage, Senior Reporter with Signal Media, and I'd like to welcome you to this online event. The opinions expressed in this webinar are of the presenters and are not to be construed as official or reflecting the views of FCA International. During this webinar, sponsored by Parasoft, we'll talk about how to leverage artificial intelligence to improve system performance as an ongoing task. Our speakers today are Jamie Modernize, Parasoft's Functional Solution Manager, helping customers streamline their test strategies, optimizing software quality, security, and reliability. And Grigory Trofimov. He's a senior solutions architect. He helps Parasoft clients achieve their software quality objectives. His job includes testing methodologies and automation, as well as fostering collaboration between development and testing teams. Having met our speakers today, Jamie Modernize will be the first to address us, but before we go to her, I strongly encourage you to ask your questions using the query box on your screen as early as possible, as there will be a Q&A segment at the end. If you'd like a specific speaker to address it, make sure to include that. Now, yes, Jamie, over to you.
Thank you, Diego, for the introduction. And hello, everybody. Thank you for joining today's session this morning. As Diego stated, we have a great presentation planned for you today. Just to start, we're going to give you a little background about Parasoft. We are a software testing solution vendor who's been in the industry for over 35 years now. And we're really focused on helping our customers to automate and optimize as much as possible. Now, prior to working with Parasoft as our product marketing manager, I worked with our customers across the DoD and federal services space. Parasoft's tools are today widely used across many programs in the DoD, the civilian federal sector, as well as by leading defense contractors, helping them to automate and optimize. We have been well on our AI journey for over 5 years now, and today we will be presenting and focusing on how generative AI practices can be leveraged by testers to optimize and enhance your existing testing practices. On the line with us today, we've got my colleague, Grigory Trofimov. He's one of our solution architects here at Parasoft, and he's excited to share with you some of our recent advancements across our testing suite, as well as some tips to consider when adopting and implementing generative AI in your test strategy. So let's dive in with a quick agenda for today. We're going to start with discussing the state of AI in software development, and we'll go over some common applications. Then we'll start to look at how AI enhances software quality. So today we'll talk about improving code quality and defect remediation, achieving testing efficiencies with unit test coverage, and helping you to automate and streamline your API testing. From there, we'll talk about how AI realizes test automation ROI, and we'll explain a little bit of what we call the productivity dip and how to avoid that. Finally, as Diego mentioned, we do have a section planned out where we'll wrap up and do a little bit of Q&A. So if you do have any questions throughout the presentation, don't hold back. Put those into the question section for us. So let's start with what is AI or generative AI. Generative AI is a type of artificial intelligence technology that broadly describes machine learning capabilities of generating text, images, code, or other types of content, often in response to a prompt that is engineered by the user. Now, you might already be using some of this in your day-to-day activities. Maybe you're working it already into your testing practices or using it to supplement some of your communication processes at your company, or maybe you're just playing with it personally, where you're using things like ChatGPT, OpenAI, Azure OpenAI, or Copilot. At the end of the day, really what generative AI is about is generating and being a force multiplier when it comes down to your manual efforts. Now, at this point, I want us to get a little bit more granular, so I'm going to turn it on over to Grigory, and he's going to dive in a little bit further into how generative AI can help us today.
Absolutely. Thank you so much, Jamie. And something to add here about generative AI is, we've talked about AI for a few years prior, right? It's something that um, has been bubbling up to the top for well over 5 years, including at Parasoft, we've been implementing solutions with various, classification algorithms and things like that. But within the last year or so, things really picked up a lot more rapidly with the emergence of ChatGPT, right? It's a very disruptive technology. The way OpenAI positions its APIs for prompt engineering, and across the government space, across the middle aerospace, we've seen the DoD come out in recent months and establish Task Force Lima, for example, to further collaborate and set up standards and policies and guidelines across the use of generative AI. We have the CDO AO, which is also heavily involved there. And generally speaking, many have come out. You see the emerging technologies director of DISA here making a statement that this is a force multiplier. This is something that uh, we can leverage and we can be more efficient and more effective with. It's also something that various adversaries are using as well, right? So when there's risk, even with technology, with disruptive and emerging technology like generative AI, you really have to embrace it because you have to understand what the risks are, what the challenges are, and how to combat those challenges. So with that, just a quick overview of how these LLMs typically work. And this example here is for ChatGPT by ChatGPT, but the idea here is that it uses pre-trained knowledge, right? It scans the web, it crawls the web, and absorbs information, absorbs massive amounts of information, whether it's text data, whether it's images, or something else that it can translate into data and information that it can use. It focuses on specific parts of the input message that you provide, right, to generate a response, and it generates the response as it goes. Uh, the way of communicating, the primary way of communicating with LLMs and these APIs are through natural language, or human readable language, right, as prompts, which is our primary form of input. And the prompt is really there to help provide context uh, to the AI generator. And they can be customized, right? So this is something that I think we're seeing a lot of even more recently is how to customize your LLMs, how to further train them to meet your specific needs and specific criteria. And a lot of organizations, a lot of teams, a lot of programs are investing heavily into uh, exposing these capabilities, exposing generative AI capabilities to really benefit their needs and meet their targets. In software development, there's quite a few common applications of generative AI. So beyond generating images or generating a slide, for example, right? From a software development perspective, there's actually quite a few applications here, and some of the key applications here are, of course, requirements analysis and documentation. So being able to automatically analyze technical specifications, ensure compliance with stringent standards, and minimizing errors uh, in terms of compliance to those standards, enhancing accuracy in software documentation, right? So not having misleading information there, and that's crucial for military government programs. Cybersecurity and threat analysis, of course, analysis of textual data, identifying patterns, anomalies, predictive capabilities for security breaches and vulnerabilities, identifying proactive measures, safeguarding sensitive information. All of those things are very much within the wheelhouse for generative AI capabilities. Something we'll be drilling into a little bit closer today is code generation, of course, software quality. So the ability to automate repetitive code generation. So we're seeing a lot of that emerging in terms of maybe defining certain models for LLMs to generate code. We've seen it be quite powerful. We've seen the ability to embed certain regulation capabilities within those code generation capabilities. And then from a software quality perspective, we're actually going to see a few different applications of generative AI. But to sort of jump the gun here a little bit, we're really looking at shift left quality practices. So ensuring clean code at the earliest stages of the SDLC. We're looking at test coverage and ensuring that code is fully covered either with unit tests or integration tests or functional tests or AI tests, depending on the applications that are being developed. And from API-led development perspectives, the ability to test those APIs, the ability to generate realistic user scenarios and to translate user scenarios into actual lower level tests is another field that we'll be looking at today. And of course, technical support and training. I mean, anything that can be used as an assistant to what we would typically do manually, right, is going to increase our efficiencies. It's going to increase productivity. It's going to help us make the team around us more productive just by being able to consume input and generate output based on the context provided in that input. And simulation and modeling. So generating realistic scenarios and documentation is vital for training. Um, i- you know, processing vast quantities of data. Um, this will all help support critical military and aerospace applications. But there are barriers to LLM adoption. So, as a independent user, right? You've probably been able to create an account and just start using ChatGPT. Well, it's not that easy, right? So external LLM provider policies so far have been a bit of a barrier or a bit of a roadblock. I think in the recent months we've seen a few LLM providers come out and provide opportunities for programs and organizations to actually leverage those LLMs without the risk of information leaking out, with certain um, protections in place to ensure that personal data is not used for training. So those types of things we still have to look out for, but nevertheless need to find a way to embrace in order to take advantage of these capabilities. The fact that LLMs are leveraging a user prompt leads to inconsistent and potentially unreliable output, right? So uh, we know that OpenAI has has times where it hallucinates, where it makes things up. There was uh, a famous case a few months ago where somebody went up, in front of the Supreme Court actually, and argued a case and used made up uh, made up precedent to argue the case, and they were quickly flagged, they were quickly identified, but the culprit there was that the lawyer was using ChatGPT to generate his argument, and you have to account for that. You have to account for the fact that it could be entirely wrong. It could be completely unrelated to the context of your prompt or the task at hand here. Performance is something that you have to consider, especially in the implementation of LLMs. If you are integrating with, say, OpenAI APIs, that does mean that until you could get output, you're looking at a full roundabout of information. Going out, querying the APIs, and then getting some output back that you can then translate into something usable for the user. Those additional steps, they do add up and can have an impact on the performance of your application or your workflow. And then the last one, at the end of the day, you look at the output from LLMs and it's easy to think, wow, I really know this stuff now. I really understand what I'm talking about. Um, and this does give us a bit too much confidence. There's always concern that uh, the confidence that we get and from this type of output could be malicious, and we can introduce malicious code, for example, into our application just because we have the confidence and we think it's good because it was generated by AI and it looks so great for everyone. So let's look at the role of generative AI and large language models in the testing space. Today, we're going to focus on three core practices, and we've kind of touched on them a little bit earlier. So number one is improving code quality and defect remediation. So shifting left, identifying defects as early as possible. Static analysis is a very common practice there that we can leverage and enhance those workflows to be more efficient with static analysis. We'll take a look at how we can do that. Achieving test efficiency with unit test coverage. So unit testing can be a challenge. Unit testing is typically something that we've embraced in recent years, but maybe not the years before. So a lot of organizations have legacy applications on their hands that don't have sufficient test coverage, unit test coverage, code coverage. They're not meeting those standards, and policies are coming out to say, hey, you have to have 60, 70, 80% code coverage. And depending on the criticality of the application, that could go even higher beyond that. So LLMs and generative AI can very much help us there. We'll take a look at how we can do that. And automating API test automation. So automating API test automation. So you're when you think about test automation today, it's still a manual process to get to that point, right? And we'll take a look at what that means. But today, you have to have domain knowledge. You have to have an understanding of how your application works. And API-led development, you have to understand how your APIs work. You have to have sufficient documentation, and you have to have real-life user examples to understand how those APIs are all connected, how all those services are connected, and stitching all of that logic together, combining all that logic together, is still very much a manual process today in the functional test automation space. So we'll take a look at how AI capabilities can assist us there as well. So starting with the first one here in static analysis, what challenges are we typically solving with static analysis? Well, we've been looking at shift left quality practices for probably well over 20 years at this point. So we know that identifying defects early stages of the SDLC means it's a lot cheaper to fix them. It means that it will take less time to fix them. The challenge is, well, actually identifying and prioritizing those defects, especially when we run static analysis. Uh, we need understanding of our code. We need to understand whether or not the certain violations or certain defects, things that are detected by static analysis code generators are applicable. We need to know how to prioritize them. We need to know how to fix them. That does require domain expertise. That does require knowledge of the code at hand. And of course, compliance requirements. Compliance requirements can be sometimes a moving target. Compliance requirements change over time. There's always a new version of a particular guideline that may be moving away from a certain type of enforcement in terms of code. Maybe it could be more process oriented all of a sudden. And so you have to meet that moving target continuously, and you have to have processes in place to ensure that those compliance requirements are met. So static analysis aims to resolve these challenges, right? By running static analysis at the earliest stages, you can define rule sets, you can define rules that meet those compliance requirements, and um, and at that point the challenge becomes, okay, how do you focus on what's important? How do you identify the most important things to fix now, or do you just try to fix everything, right? And so generative AI can help us here a lot because um, over time, as we train our models and we continue to run static analysis, as a part of our continuous development process, we should start to see some patterns. We should start to see patterns in terms of what violations could potentially be false positives. We could also see patterns in terms of how we address a certain violation, right? If it needs to be suppressed, if it's actually more an informative type of violation rather than a critical violation that we need to address immediately. If it needs to be assigned to a certain team or to a certain group in order for that violation to be remediated, right? So generative AI can learn from these things, or there are other algorithms as well that can learn from these things and essentially cluster violations based on precedent, based on how these violations have been addressed in the past, or assigned, or suppressed, or even fixed. So with generative AI and its code generation capabilities, we can actually fix the violations as well. So when static analysis violations are identified, we can feed examples of what would trigger said violation versus how to fix a specific violation, and feeding that data will allow OpenAI or Azure OpenAI, any LLM provider at that point to generate code that would actually fix the violation. So this is aimed at, of course, improving efficiency, improving productivity. As a developer, you have to you have to validate it, right? You still have to review it, but it does cut down the time of actually having to write the code and come up with the right solutions to fix a specific violation. One of the things that Parasoft does really well is when we identify static analysis violations and defects, we will also provide the trace of the said violation. So that additional kind of information um, allows users and provides additional context to the violation and the right way to address it. So looking a little further ahead into unit test coverage. Um, Organizations have been struggling with unit testing for since the dawn of code, really. And you know y- you look at the way, let's say, for example, Google defines code coverage and what it is an acceptable standard of code coverage. They'll say something along the lines of, 80% is actually great, 85% is superb, and then beyond 85%, you're actually pushing into territory where the returns on that additional 5% of code coverage could be marginal, right? You have to take a step back and you have to think about the application, the goals of the application, what the criticality of a specific application is to determine what is the right level of code coverage for you. But we can all agree that when you write code, you should also write unit tests. And this may have not have been the case with the application that you're actually working with. So we work with many programs, many organizations who come to us and say, you know, we have over 3 million lines of code here. We have less than 5% code coverage, but we don't really expect to change, all that much of it. So, what do we do? We need to achieve 60% code coverage, but do we go back now and do we write all these unit tests? Not to mention, at the time the application was written, chances are it wasn't written with unit tests in mind, right? It wasn't really even written maybe with units in mind. It was it's a monolithic application with millions of lines of code with tons of logic nested into individual classes and methods. Not something that uh, that we like to do today, right? Today we really focus more on uh, distributing logic, microservices architecture, so on and so forth. But in any case, creating meaningful unit tests in those instances, very difficult. But using AI technologies, we can we can provide a more assisted flow to developers to create meaningful unit tests. Achieving code coverage targets, there has to be a way of analyzing mass data, lots of data at once, and being able to basically spit out enough tests to meet code coverage standards. And maintenance. So maintenance will always come back when we talk about testing of any kind, but for unit testing, that goes as well because from a unit testing perspective, our code changes all the time. So when we make even minor changes to the code, what do? Do we have to run all of our tests all at once and see what tests are impacted by those changes and rework those tests, or do we use naming conventions to identify the tests that are impacted by those changes? Well, there are things like test impact analysis. There are ways for us to actually scan the code, understand based on code coverage what tests are associated with what changes in which lines of code, and we can reduce some of that overhead for developers. So in this instance, we did an interesting exercise. So Parasoft, we have a solution called JTest. We've provided unit testing capabilities for well over 10 years now. And so with the emergence of LLMs, with the emergence of OpenAI, uh, we've we've kind of wanted to compare, how those things stack up against us. And this is a very simple a class here, a Fibonacci sequence, and we've asked um, uh, ChatGPT or OpenAI to generate some tests for it. in comparison to our solution, the way we have always traditionally looked at it is, these tests, they have to work in a professional development environment, right? So they have to be consistent. The format has to be consistent. There have to be assertions. There have to be some inputs. There have to be some given values, and it has to be human legible, right? At the end of the day, if a human can't review it and read it and acknowledge that, this method under test or this class under test is thoroughly tested, then it does not provide value and it does not hold up, in the context of a professional development environment. With ChatGPT, what we saw is, number one, these are working tests. So it didn't fail in its mission to generate unit tests that are that cover these lines of code. But what you do see is the inconsistency, right? And you ask OpenAI the same thing twice, you're going to get two unique responses. Uh, But what it does do well is it does pick values well. It picks assertions well. It's good at extracting the context of the code itself, and setting up the test. At the end of the day, the output is a working test. So when you look at these two approaches, what you start to find is that, you want to bridge the best of both worlds. You want to alleviate some of that unreliability and some of that inconsistency that comes from LLMs or from OpenAI. But then you do also want to enhance uh, what we have today. You want to enhance those common flows with the capabilities, with all of that mass data that it's able to absorb, uh, and train itself in order to give you good values and generate good test data. So some other takeaways from our observations and comparisons. Again, uh, OpenAI LLMs have great conceptual understanding of the code, but there is high variability in the generated test. You actually may get code that may not necessarily compile or may have errors or may be incomplete. So there is an element of OpenAI, expecting the user to interpret their output and use that output and embed that output somehow into their own workflows, whereas our solution is focused on achieving those code coverage numbers and testing those all the individual paths and the individual conditions within the method under test as much as possible, and those tests being ready for execution for production. Um, yeah, LLMs, they can also get outdated, so that's kind of one thing to consider as well. Is working with LLMs, working with large language models, you have to consider that they may not have knowledge past a certain point, and that can also affect the quality of the output and the quality of the test that it returns. And performance. So I mentioned performance initially, but integrating, getting responses from LLMs or OpenAIs does take longer than, say, generating code on-prem or generating code within the browser, which is what we do with JTest today. So combining those two capabilities gives us a very powerful workflow in terms of achieving good unit testing, meaningful unit testing code coverage. So we leverage our capabilities in terms of setting up the tests and formatting the tests and ensuring that they are runnable, compilable tests. And we leverage what OpenAI is good at, which is obtaining context from the code at hand and generating good test data, and optimizing those tests. And for when we look back at, let's say, the legacy application use case, the workflow there then becomes, hey, let's start with uncovered source code. Let's start with our 2 to 5% code coverage. Let's generate as much code, unit testing code as possible, but also leave room for us to then go in and enhance and get those additional 10, 15% in a more assisted test creation flow, right? This will give us um, a more targeted approach, a more focused approach, and also give us the ability to optimize our tests and not have tests that you know maybe cover the same lines of code over and over and over again, but rather tests that actually test unique individual units based on Parasoft JTest input, the user input, and OpenAI input. So between all three of us, right, we should come up with high levels of code coverage with meaningful unit tests. So finally, looking kind of at the top of our, or a little further up in our test pyramid, we'll see the test automation pyramid here shortly. Looking at automating API test automation, as is with general functional test automation, we're moving a little bit away from the code. We're focusing on the function. We're focusing on the functionality and the end-to-end flows of our application under test, of whatever it is that we're developing. And the challenges there are, test scenario creation automation, again, it's still very much a manual process. We have teams that build the APIs, and then we have teams that test the APIs. And that domain knowledge isn't always translated from developers to the QE team, or to the product owner or the program owners, whoever's responsible at actually for defining user stories and implementing those user stories as automated tests. We do have documentation, we do have specification files. So in API-led development, typically we'll see something like a definition file or an open API or a swag file, right? That describes the resources, describes what a particular service does, whether it's updating account information or updating uh, a cart, or um, some sort of registration information, right? Those things are typically documented in the service via definition files. And then the other thing to keep in mind here is that different organizations are currently in different stages of implementing their open AI integrations, their LLM integrations. Everybody is looking for ways to enhance productivity. Everybody is looking for ways to leverage those tools and leverage open API and LLMs in their workflows. But not everybody knows where to start, right? You can't just expose these capabilities to everybody, because there's the risk of somebody doing something malicious with it, or uh, just flat out getting bad information. So there has to be a nuanced and a controlled way of introducing these capabilities or introducing integrations, especially when it comes down to QE. The Parasoft Continuous Quality Platform for API testing, we do offer quite a lot of capabilities there. So to start with, before we get into our OpenAI capabilities, this is really a kind of a Swiss Army knife when it comes down to functional testing. Whether you're doing UI testing, whether you're doing backend testing, performance testing, there's API and security testing capabilities. Penetration testing, even service virtualization for scenarios where your test environment is not stable. If you have external dependencies or third-party applications that you need to integrate with, or that you need to deploy during the deploy and the regression test stage of your pipeline, you can leverage service virtualization capabilities to stand up simulations or digital twins of real services in order to stop those out and remove those constraints from the environment. Focusing on the API testing layer, again, this is kind of where we see a lot of challenges of specifically translating user requirements into API tests. Uh, even internally, we've had these challenges. When we develop APIs and when a user does something, it turns out that maybe a different set of APIs is getting called than what we actually have documented, or what we may have expected from that particular service. So we've developed capabilities for us to identify those things and for us to help translate acceptance criterias and user stories into API tests, and reduce some of the manual labor associated with that, and also improve our accuracy and improve our overall test coverage and the different permutations of user flows that we can consider within the application under test. There's two primary approaches to that. For web applications, what you can always do is you can actually capture a manual test case, or an actual user flow essentially within your application. Say it's a finances management application or a banking application of some sort, right? You can always record yourself as a user. I can log in and I can open a new account. I can transfer funds from one account to the other. So one way to do it is by capturing those UI interactions, listening on the HTTP traffic and listening for the network traffic, and then applying certain rules and applying AI logic and classification algorithms uh, to basically stitch together those API calls that are happening a layer below. A lot of times, what you see is, kind of opening up the box, right? You're opening up the box to see what's under the hood, and how things work. And you could be capturing API calls to some middleware services. You could be capturing API calls, to the API gateway. But in any case, it's a nice, quick way and an easy way to understand how your application works, automate otherwise manual tests, automate what could potentially otherwise be UI tests, which are very performance intensive and take a long time to execute, and have something that runs a little bit more consistently. And when you do identify defects and when you do identify some issue within the application, you have a much more focused area to look at in terms of identifying how to remediate um, those defects. Of course, the key thing here is to continuously train our models, to train the solution to do better next time, right? If initially maybe we had a recording and certain APIs didn't get parameterized, the way we would expect them to, we can train the model. We can train the template and say, hey, going forward, when you see this traffic, do this, and it will pick up on that, and it will learn over time and do better. So this is the record and replay workflow. The other workflow is, again, for API-led development. If you don't have a front end, if you don't have a UI for your web application, you have services and you have definitions for those services, and you need to generate automated user-based end-to-end flow type API tests. Well, this is where OpenAI, this is where LLMs can really help us here, because we can provide that definition file, right? We can tell a an LLM, look, this is what the service looks like. These are the resources. These are the APIs being called. Now, as a user, I need you to give me test scenarios for this, and this, or generate a bunch of test scenarios for me that then I can go through and choose which ones I find applicable, which ones I want to implement in my test automation pipeline. And the output is the same, right? The output is automated test scenarios that we can then inject into our pipelines. We can run, on check-in or on merge, basically triggered by whatever code changes occur in the application under test. And of course, continuously training the model, training the solution to be better and to generate test scenarios closer and already pre-configured as much as possible for us to simply just, maybe add a little bit of data that we need that we don't want to pass in initially, or basically just check those tests into source control and have them run as a part of our um, regression suite. So this is kind of like an infer and generate workflow versus a record and playback. And this is actually what we'll show today in our brief demo here. So I'm going to go ahead and switch perspectives. And today we're looking at Parasoft SOA test. This is our API testing solution. Uh, it has all the capabilities that you would expect to see from a modern API testing tool, whether you're testing REST APIs, SOAP, uh, Kafka, GraphQL, right? We support over 120 different protocols and message format types. Whether you're doing UI testing or you're testing your databases and ensuring that the data, in the from a user's perspective, matches the data that's on the back end, right? You can do those types of end-to-end tests. But from an API testing perspective, you have these sort of traditional conventions of creating API tests. And if you're creating an API test, let's just go ahead and do that here. I may have a Swagger or an Open API definition file. Again, these are the definition files that you typically use to describe the capabilities of your APIs. And what you typically see from API testing tools is the ability to generate individual clients, right? It's just going to read your spec, it's going to read your documentation, and for each resource defined in that documentation, it's going to generate a single test. And that's great if you're talking about smoke tests, or health checks, right? Or maybe even some sort of negative testing scenarios, where all you really need is the individual resource. That resource turns into an API test client. You add your data, and then you can run the test. But that doesn't validate real user flows. What does validate real user flows are test scenarios, where the API calls have to be sequenced in a certain order in order to be valid, and in order to represent a real user experience. And so what we have here is a prompt, right? This is a natural language prompt. This is something that anybody can go in and type in what they really need from a test perspective. They can explain in their own words how they need the tests to be structured. There are examples, for inspiration in terms of what you might want to do. So, for example, my service definition file is for a banking application. So I may want a test scenario that focuses on the bill pay functionality. Or I can actually be a little bit more explicit in terms of what I want OpenAI to do in this particular scenario. So I can, for example, I can define a whole mindset, more or less for OpenAI to give me output here. So I'm going to go ahead and click generate, and while that's generate, we can take a look at the prompt here. What I'm telling OpenAI here is, look, you're a software tester. You're validating, a standard banking application called Parabank. Generate some interesting complex scenarios. Just give me what you think is right based on the described resources, and a few things to account for. Number one, account for the fact that a customer already exists in this in the context of this application, or in the context of these test scenarios. Also, add some additional steps like a login step. Maybe I want to enhance my tests with penetration testing and ensure that the login process is secure. Add some end-to-end operations and additional steps for validation. So those additional steps for validations are important. That's how we set up our assertions. That's how we ensure that the data that gets returned from our test is valid and consistent throughout the user experience. And the output that we get here is actually pretty good. So number one, we get a good description of what it is that we're trying to test. Transfer funds between two accounts. Okay, great. Let's take a look at that. And we have a flow. So user logs in. They withdraw some amount. They transfer some amount. It looks like we got another login. So here's a great example of where sometimes OpenAI does and shows weird things. But as a user, it's pretty easy for me to review that and say, well, that doesn't need to be there. That's not supposed to be there. We don't need to do another login in order to do this scenario. I wouldn't expect users to log in and then log in again. Now, they could get timed out potentially, but that's a different story. That's a different user flow. Um, and you can do this with all of your tests, right? So you can go through, you can find the scenarios which are relevant, scenarios that you might want to keep, and it looks like it's just trying to stick this login here everywhere for some reason. And select the ones that are applicable and select the ones that make sense, or maybe some of them don't make sense at all and you want to get rid of them and you want to generate more, right? So on top of what you already have, I'm going to keep the ones that I like, and then I'm going to continue generating tests. Now, this is a very powerful and a fast way for us to get lots of different user scenarios and embed a significant amount of test coverage for our APIs just by generating user scenarios. We could also completely start from scratch and just regenerate all of them and say, do better next time, maybe enhance our prompt a little bit in order for it to be a little bit more accurate in the test scenarios that it generates. We can also leverage things like feature files, BDD, right? So a lot of our acceptance criteria already uses what's called a given when then format, where we define what we uh, what we would expect from the application in the context of the user, right? So as a user with an existing account, when a user logs into Parabank and deposits some amount into the account, then the account will have the deposited amount. Let's go ahead and click regenerate here. So this, again, this is something that you might already have in Jira. This is something that you might already have defined as a set of feature files that you could be using Cucumber or a spec flow or something like that, right, in order to drive your BDD scenarios. But also using this type of language helps OpenAI, and it produces maybe more focused, less results, but it's more focused, and it actually looks a bit more accurate, right? And so if I go ahead and um, click finish here, the tests that get generated for me are just about ready to go, right? These are good scenarios here. And we have the full description, we have the prompt that we used in order to generate these scenarios, and all that's really left is either adding some data. For something like username and password, we probably want to use secure data. Um, Also note that we've added assertions and data banks, right? So automatically we're picking up on certain values that need to be validated on, like the balance within the account, or if we need to store some data bank value, like an account ID, and pass it on to a subsequent API call, we're setting up those things within the test automatically between ourselves and between what the output from OpenAI gives us. And so how that actually translates into gains, into productivity gains, well, all you really need to do is look at this productivity dip. It's a the productivity curve is um is a common common understanding, right? That when we embrace new technology, when we try something new, initially we're probably not successful, and it takes time to learn and to be efficient with the new technology before we reach the level of mastery where we excel, and where we go beyond what we had initially. So what we're finding is that LLMs, OpenAI, are extremely effective at addressing this productivity gap. Overall, at the end of the day, when you reach the mastery phase, you're going to probably see more marginal uh, benefits. Or at the end of the day, you don't want you want to be the expert in between yourself and OpenAI. You still should be the expert, right? But initially, in those initial stages, when you're not the expert and you need to get up to speed and you need to learn faster, OpenAI and LLMs can go a long way there for you, and help you achieve greater productivity. So overall, if you look at a Parasoft suite of solutions, we do offer AI integrated solutions across the full spectrum of the test automation pyramid, whether it's static analysis, unit testing, API testing, UI testing, or even manual testing. And I think with that, actually, Jamie, I can go ahead and turn it over back to you.
All right. So we are getting to the end of today's presentation. Again, if you do have any questions, make sure you put them into the question area. We'll be addressing them in just a few minutes. But he did just want to kind of recap real quick as far as how generative AI is being used in software testing today. So, keep in mind when you're thinking about generative AI, it is still an emerging technology. We're only just starting to scratch the surface of really what's possible with it. So today we did go over some ways that it is benefiting test generation and the testing community as a whole. But this is still emerging technology. We're only still scratching the surface of what's possible. So, I'm excited to where the future is going with this. Um, at the end of the day, the main things that we see when it comes down to generative AI as far as benefits is helping testers to increase the thoroughness of their testing practice, improving their use case coverage. As you saw with that short demo that Grigori provided, you're able to rapidly create a large number of different test cases to maximize your use case coverage and really ensure that your software is going to be thoroughly tested so that you can release with confidence. Generative AI alone does have its limitations. We talked a little bit about them today. Yeah, it's really based on what is the data that you're training it on, as far as getting consistent and accurate output. So we really recommend that when it comes down to generative AI, you want to combine it with tried and true tested solutions in the industry that are going to help you to sort out, to filter through the noise and provide you with really benefits for optimization. And then finally, at the end of the day, I know there is a lot of concerns about generative AI, replacing the human tester. The way that we're viewing it, and I think most of the community is viewing it today, is that this is really more of a full force multiplier. It's all about getting you better processes, optimizing your activities, reducing the manual efforts you're putting into creating new test cases, and really again just maximizing the efforts that you're already doing. So it's a great way for you to increase the benefits from your existing efforts. So go on. Got one more slide here, I think, for you. So we'll go into the Q&A in just a second, but today we saw that very short demo. It was only on the API testing side, but we did talk about some other ways that generative AI is benefiting testers. So both on the static analysis side, the unit testing side. If this is of interest to you, we highly recommend that you request a demo. So you can request a demo there through the QR code. That would be a technical demo where our team will connect with you, understand really kind of the challenge place or your area of focus. And then from there, we'll get you guys a customized demo, walk you through technically how these tools really work. And then we also put up there the Forrester Wave report. Parasoft participates in this quite often, and we're always named a leader in the industry. But if you did want to get a little bit more information, granular details about, why Parasoft is recognized as a leader for continuous automation testing platforms, I highly recommend that you download that report. All right, let's look a little bit at these questions. So Grigori, we have one that's what LLM models does Parasoft support today?
Today we support today we support actually a few flavors of GPT 3.5 and GPT 4 models. GPT 3.5 Turbo, 16K, and so on and so forth. So there's quite a few those GPT 3.5 and GPT 4 by OpenAI and Azure OpenAI are the primary models we're supporting today, and they are likely the most common and the most popular models that we see across the industry there as well.
Okay, perfect. And then we have this one. Where should a team or organization start if they want to adopt generative AI? Do you have any recommendations there, Grigori?
Yeah, absolutely. And actually, also I see there's a question here from Jonathan. I think along the same lines here. Um, First of all, Jonathan, thank you very much for your question. Thank you for your service. Uh, well, just like with anything, nothing beats hands-on experience. You can watch Michael Jordan videos, but you're not going to play like Michael Jordan. So at the end of the day, you have to go out there. You have to try these things yourself. There's a few things to consider. Number one, it's an emerging technology. That means we are going to see a lot of changes, I think, in the next few years to its capabilities, to its pervasiveness across our everyday lives. And you have to account for that. You have to account for the fact that you're not going to pick up everything at once. This is going to take a little bit of time, and you have to leave room for trial and error. So you have to leave room for trying something and even allowing it to fail, and maybe trying multiple things at once, so that some things can fail and some things can succeed. As far as resources, that'd be actually a really good idea for us to maybe compile some resources that we can share for our audience to look at, outside of Parasoft. But Parasoft also does offer trials for our solutions. So if you do want to get some hands-on experience with, say, unit testing or static analysis capabilities or API testing capabilities, please reach out. We'll be more than happy to facilitate that for you.
Wonderful. And then we have a question from James. Thank you for sharing. Will you be making this presentation available externally? Yes, we will. And then I think there's just one more in here. Let's see. Oh, do you have any tips on getting management to approve and adopt generative AI?
Uh, you know, any any conversation with management, you're going to have success with a data driven argument. I would point to widespread adoption across the software development spectrum. I would point to even the Signal magazine has done great articles on how various programs are approaching OpenAI, and how to think about it critically, right? Uh, at the end of the day, if you miss the boat, there's going to be other boats, but the first sellers will get the first, the access to most of the resources. So it's a business decision. It has to be driven by business driven data at the end of the day. And so in making that argument, you have to do that.
Yeah.
I see there's another question here, actually. I think it just popped up about vector databases. In our experience with vector databases, this is a great question. So this is something that we are fully in research mode. I think we have some ideas on best ways to implement it. Definitely from a perspective of triaging results, storing results, storing data, and analyzing that data, and producing good output efficiently and enhancing performance that way. There's a lot of promise there, but at the moment it's mostly in research stages on our end. So we'll be sharing more news as we have some more things to offer.
All right. I think that's everything for questions. Thank you everybody for your time today. We really appreciate it. Again, if you are interested in doing a deep dive into our technology and seeing how exactly we are able to leverage AI and generative AI capabilities, I highly recommend requesting a technical demonstration with our team. We do have some additional content that Signal has around Parasoft's AI capabilities as well. As I said, we've been on our journey for AI and machine learning for about 5 years, a little over than 5 years at this point. It's worth looking into other aspects of how we're implementing traditional AI to help teams streamline and optimize all of their testing practices. Now, at this point, I'll turn it back on over to Diego to take it away.
Thank you very much, Jamie. Yes, as you both said, here at Signal Magazine, we're working very, very hard covering AI and trying to offer, a little bit of the latest. But well, with this, we end our Q&A today. I'll get back to this soon. Before we end our session, I'd like to ask our speakers to just give us a quick summary, short conclusion from both of you, if possible. Over to you, Jamie.
So end of the day, generative AI is emerging technologies. AI, though, has just been in the testing space for quite a while. There's a lot of benefits when it comes down to test generation, helping you to optimize, helping you to streamline, and really helping you to increase your test thoroughness. At the end of the day, the software that you're creating, oftentimes it's being put into the hands of people in the services where we really need to make sure that it is going to be safe, it's going to be secure, it's going to be reliable, and really that's what Parasoft is all about. So if you do have any specific challenges around testing, you're interested in a little bit more of this topic, I urge you to reach on out to us. We're always happy to talk test automation and innovations.
Grigori, do you have a...
well, I don't even know what I add to that. Yeah. I have to reference that full force multiplier. It's that's such a great phrase for OpenAI and LMs. That's exactly what it is. And you have to embrace the risks of emerging technologies in order to know how to be prepared for them. So hands on, full steam ahead. Looking ahead to the future.
Jamie, Grigori, thank you very much. I remind everybody you can view this webinar on demand and see previous Signal webinars on Signal's website at afcia.org/signal-media/signal-media-webinars. There you will find further resources on today's topics, and you can dig deep. Important thing, if your questions weren't addressed during this event, we apologize. We will forward your query to our panelists. And this concludes our Signal Media webinar. Again, a big thank you to our sponsor, Parasoft, and to all of you, thank you for being with us. See you next time.
Thank you, everyone. Thank you,
everyone.
Diego.
Bye-bye.